Okay, so the first thing is, remember, everything is respect to time, right? Everything, because it's a rate. So everything is with respect to time. So it's over dt, right? That's the first thing. Every rate is dt, okay? The second thing is these steps here, following these steps. The more faithfully you can follow these steps, the easier this will all be, okay? Now, for today, step 4 isn't going to be necessary. Okay, so step 4 isn't going to be necessary for today. For tomorrow, it will be necessary. So the first thing we got to do is write everything that's given. Okay. The second thing we got to do is, what do we need to find out? Okay. The third thing to do is look at the question. Create an equation based on the question. If it's asking for area, we need an equation for area. If it's asking for the length of a side of a triangle, we need an equation that'll give us that. Okay, so that's the third thing we need to do. The fifth thing we need to do is find the derivative. And then the last thing is plug and solve. Okay, so those are the things that we need to do for all of these problems today. Okay, so let's look at, and then these are a couple things that are important. Remember, if it says the rate is decreasing, that's going to be a negative number. Okay, if this says the rate is increasing, that's a positive number. Product rule, we will have to use the product rule today. All differentiation is implicit. Okay, so that's important to know. Units we don't really worry about until the end. Okay, don't worry about units until the very end, and then label. Don't plug in numbers into the original equation for things that are not constant. We'll talk about that, what that one means as we go. Okay. Okay, so we did one. Now let's look at example number 4. Example number 4. Okay, so we're going to go down the list. Step 1, step 2, step 3, step 5, and step 6. Okay, so step 1. What does step 1 say? What does step 1 say? What do we know? So write everything down that we know. Okay, I always draw a picture because pictures help. So it says a right triangle. Okay, so let me draw a right triangle. Doesn't matter how it looks, just matters that it's a right triangle. Okay, has legs of 33 and 44. So legs are the short sides. Okay, so legs are the two sides that make up the right triangle. So one of them is 33 and one of them is 44. So we'll call this 33 and we'll call this 44. Okay, whose sides are changing? Okay, the short leg is increasing. Let me move this out here. The short leg is increasing by 4 inches every second. So 33 is getting bigger. As we speak, every second, it is getting bigger by 4 inches. Okay, so that means this side right here, this dot right here is moving this way. And this is increasing. 33 is increasing. Well, if 33 increases, the long leg is shrinking by 10 seconds. So this side right here. So this guy right here is shrinking, is getting smaller by 10 inches every second. What is the rate of change of the hypotenuse? Okay, what is the rate of change of the hypotenuse? Okay, so we drew a picture, but let's list what we have and what we know. Okay, so again, anything, any side that's horizontal, we're going to call x. So let's call this guy x, and any side that's vertical, we're going to call y. So we know that x is 33, and we know that y is 44. Okay, that's the first two things they tell us. What's the second two things they tell us? The short leg is increasing by 4 inches. Increasing by 4, that means positive 4. The long leg is shrinking by 10 inches per second. Shrinking means getting smaller, negative, right? How do we label those? How do we label what equals 4 and what equals negative 10? What are we going to put here and what are we going to put here? Yeah, Pete?
Dx over dt equals 4.
Good.
Dy over dt equals negative 10.
Very good. Just like that. Yep. Just like that. Okay. Is there anything else that's not listed here that we do know? Is there anything else that's not listed here that we know? Double check that. Is there anything else that's listed here that we don't know? Okay. What are we trying to figure out? What is it that I need to find out? What is it? What is it that is the question gets the question mark, right? What is it that I need to know to solve the question, to solve the answer, to solve the problem? Mhm. The hypotenuse, right? How much the hypotenuse is changing, or how fast is it changing, right? So how do I write that? Let's call the hypotenuse, you could call it h, but when we do some of these, you're going to get some of them are going to be three-dimensional objects, and h is used for height, right? So instead of h, let's use z. Since we're using xy, let's use z. Okay, so how do I label this guy over here? What am I going to do to label that guy? I know how to say it in words, the rate of change of the hypotenuse. But how do I label that on my list? There you go. dz over dt. Good. Okay. Step 2 done. Step 1, step 2 done. We listed everything we know, labeled what we need to know. Okay. Step 3. Step 3 says we need an equation that will relate. Let me see, what is it exactly? Let's see. We need an equation that relates the variables x's, y, z's, dz, dt, dx, dt, dy, dt, and we'll answer the question. So what equation that you guys know that will help us do that? There you go. Yeah, the Pythagorean theorem. Exactly, the Pythagorean theorem. That will relate side lengths and hypotenuse lengths, right? It's not asking about area, right? Didn't say anything in there about area. So I don't have to worry about any type of area equations. Didn't say anything about volume. It said talks about hypotenuse, right? A squared plus B squared equals C squared. Good. But we labeled ours differently, right? We didn't label ours A squared plus B, A, B, and C, right? What did we label ours? X, Y, and Z, right? So the equation we're going to use is the same with different letters. Okay, that's the equation we're going to use. Okay. Step 3 done. Step 4, we're going to skip. Step 5, differentiate. So find the derivative of that guy. Next thing, find the derivative of that guy. Okay, so the derivative is 2x dx dt plus 2y dy dt equals 2z dz dt. They all need tags because none of them are time. And it's always with respect to time. Okay? That was step 5. Step 6. Plug in what we know, right? We know some of these, right? So we're going to plug it in. So this is what I always do. The 2's is just a constant, right? Or sorry, coefficient. So anywhere there's a variable, that's where I'm plugging stuff in. Plug in what I know. I know x. It told me x. X was 33. Dx dt. I know dx dt. All right, that was 4. Y is 44. Dy dt was negative 10. Z and dz dt. Well, dz dt, I don't know. This guy right here, that's where the question mark goes, right? Z, do I know Z? I got everything except for I knew dz dt I wouldn't be able to get, right? Because that's what I'm trying to solve for. That's the question, right? But Z I don't have. Is it on my list? No. What do I do? I have enough information where I could solve for Z, right? I have enough information. I know X, I know Y, I know this is a right triangle. I could use this equation here to figure out that guy there. Okay, I could do it. So I'm going to have to because I need it, right? So let's see. 33 squared plus 44 squared equals z squared. The nice thing about related rates questions is they're always calculator questions. Okay, so they're always calculator questions. So we can use calculator on these questions because sometimes you're dealing with decimals, fractions, sometimes you're dealing with some things like that. So I get 109, 1089, I should say. 1936. Add those two together. And I get 3025 equals z squared. Let's see if it's got a square root. Yes, it does, 55. Okay, oops, not z squared anymore, it's just regular z. So z is 55. So we can go up here and label 55. They didn't tell us that, but we had enough information given that we could figure that out. We could find that out using Pythagorean theorem. Okay. All right. Now let's go plug that in here. 55. Okay. So now we only have one unknown in this whole mathematical statement. We only got one thing we don't know. So if we only have one thing we don't know, we can solve for it. Right. So instead of the question mark, I should put what we're actually doing here. Let's see, which is we're trying to find dz dt. All right, so if I multiply those three guys, I get 66 times 4, which is 264, plus 2 times 44 times negative 10, negative 880. And then over here, I can just go 110 dz dt. Okay. I can combine these two guys here. I get negative 616. Okay. Divide by 110 to get dz dt by itself. Here's the thing about it. It's always best to leave it as a fraction, because if you change it to a decimal and you round wrong, it'll mark you wrong. Okay? So what I always try to do is reduce the fraction. Reduce the fraction as much as you can, because fractions are always going to be correct, but sometimes I've seen students who change it to a decimal, and you'd be surprised how many students don't, I don't know if they don't know, or just they when they round, they round poorly. And like they'll be off by one decimal. Like the answer, I've seen this happen before. This has nothing to do with the question, where they'll say the answer, they'll put their answer down as that. And the correct answer is this, because they rounded poorly, right? So I always stress, unless they say change it to a decimal, just reduce your fraction. Just reduce your fraction, okay? And you can use a calculator on these questions, so reducing fractions isn't that bad, okay? So like if you divide them both by 2, you get 308 over 55. And then if you divide them by something else, you can divide them by, I think. 308 divided by 11. 11, you can divide them both by 11 as well. So it's 28, negative 28 over 5. Okay. Now we got to bring in units. What units would that guy, what units would this be? Inches, seconds, inches per second. What units would this guy get? If it's a length, it's going to be inches. If it's time, it's going to be seconds. If it's a rate, it's going to get distance per time. So what are we going to label this guy with? If it's area, it's going to be quantity squared, because area, if it's volume, it's going to be cubed, right? So what is this guy going to be? Yeah, it's a rate, and we're talking inches and we're talking seconds, so it's just going to be inches per second. Yeah. Okay. The last thing to do, I didn't put this on the list, but it's kind of something you do in your head. Does that number make sense? Does the number make sense with the question? So the hypotenuse is decreasing, is getting smaller. Does it make sense in real life? Does it make sense in, because a lot of times what you'll do is, not a lot of times, but sometimes what you'll do is you'll do all this work and you'll get a negative number. And you shouldn't have got a negative number. You should have got a positive number. So does it make sense with what we're doing here. So if this side is getting bigger by 4, and this side is getting smaller by 10, should this side be getting bigger or smaller? If this side right here is getting bigger by 4, and this side right here is getting smaller by 10, so it's shrinking down. So this side is shrinking down. This side is getting bigger. So does it make sense that this side is getting smaller while those things are doing it? Yeah, it does. Okay, it does. All right. Okay, so what I want you to do is do 5A. 5A. If you finish 5A, do 5B. I'll give you about 5 or 10 minutes to do that. Try one on your own. Okay? Try one on your own. Okay, so let's take a look at part A first. Part A, if you're not done, that's fine. We'll do it together, but let's take a look at part A. Part A said, I listed what I had. So I listed everything that I had. It told me Z, the length of the ladder. The ladder is 25. Well, the ladder is the thing that's going to be diagonal. That's going to be the hypotenuse, right? And then it said the bottom of the ladder is being pulled away. So if a ladder is standing diagonal and you're pulling it away, that means the bottom is getting bigger. Okay? So if the ladder is standing diagonal, if you can picture a ladder, like the foot of the ladder there and the top of the ladder up there on the wall, and I pull it away, that means it's getting bigger. The length on the floor is getting bigger. Okay? So in other words, this is getting bigger. This is the bottom of the ladder. It's getting bigger. So y is getting bigger. dy dt is getting bigger by 3. Okay? Or sorry, I labeled this wrong. Let me change my labeling. This is supposed to be y. This is supposed to be x. And okay. And then part A says, how fast is the top of the ladder moving when the bottom is 15 feet away from the wall? So now it's saying, okay, so the bottom is 15. The bottom's getting bigger, but right when it's 15, at the second it's 15. How fast is the top of the ladder? Well, if I'm pulling the ladder away, the bottom 15 is getting bigger, but what's happening to 20? Is it getting bigger or smaller? Smaller, right? So this guy right here is decreasing that way. We want to know how fast is it decreasing. So we're expecting a negative number when we're done. Okay? So that's my unknown. It didn't talk anything about the hypotenuse. How do I know that the hypotenuse, how did I know this guy right here? How did I know that guy is not increasing at all? When you say it that way, it makes sense. But how did I know this dz dt is equal to 0? Huh? Yeah, the ladder is 25 feet, right? I can't make, the ladder's not getting bigger or smaller. It's a ladder, okay? It's a ladder. So as I pull this way, and as this guy goes in this way, the ladder is going to stay the same. It's a constant. Okay, so it's not getting bigger or smaller. And then y, I figured out was 20 using Pythagorean theorem like we did on the last problem. Okay. Okay. So they want to know, so an equation that relates all of them for A, Pythagorean theorem again. Okay. Step 5, I found the derivative. Last thing to do is plug in. Okay. So plug in what I have and solve for what I need. So 2 times x times dx dt. 2 times y times dy dt. 2 times z times dz dt. X is 15 and dx dt is 3. Y is 20 and dy dt, I don't know. So that's what I'm trying to figure out, dy dt. Z is 25 and dz dt is 0 because that's not increasing or decreasing at all. Okay. The only thing left is dy dt, and that's what I'm trying to solve for. All right. So multiply those guys, I get, let's see, 600 and, let's see, was that 39, or sorry, 90 plus 40 dy dt equals 0. Okay. Subtract 90 from both sides. Dy dt equals negative 90. Divide by 40. Negative 9 over 4. Negative 9 over 4. We said it would be a negative number because if I'm pulling out the bottom, the top's getting smaller. The top of the ladder is getting smaller. Where the ladder hits the wall is decreasing. Okay? So that is feet per second. Feet per second. Okay? The nice thing about B is that a lot of what we use is going to be used again. They're asking a different question, but a lot of the numbers that we use, x, y, z, dz, dt, dx, dt, all of those things, is going to be the same. Okay? So how fast is the area? Now it's talking about area. So right here. That's giving us a big hint on what we're going to do for step 5 and step 6. How fast is the area formed on the wall and the ladder changing when the bottom is 15 feet? Start step 1. What do you know? Well, a lot of what we know is still true. A lot of what we know is still true. Okay? So we can still use our picture. You can draw a new picture if you want. If you don't want to draw a new picture, you don't have to because the same picture is going to apply. It's the same question, just the same problem, same prompt, different question. So the bottom is still 15. The ladder is still 25. That means the wall from the bottom to the top of from the floor to the top of the ladder is still 20. Okay. So let me draw it one more time. X, Y, Z, so this is still 25, this is still 15, and this is still 20. None of that's changed. Okay, so let me label that X 15, Y is 20, Z is 25. Okay, let's go back up. How fast is the area? So we know, now we know these things, right? We know dx dt, we know dy dt, and we know dz dt. So let's write those down as well. Since we know them from the last problem, dx dt, dy dt, and dz dt. Okay. So x is 3, y is negative 9/4, and 0. 3, negative 9/4, and 0. That's all taken from the last problem. What do we need to find out right now? What's the question asking that we don't have on our list? This is everything I know. So this is step 1. This is everything I know. Step 2, what do I need to find out? What do I need to answer the question? Now it's asking for area. So how do I write that over here on my list? What do I need? No, I don't have formulas over here. I have list of things that I need to know or that I know. There you go. D capital A over dt. That's what I need to know for step 2. Okay. That's what I need to know for step 2. Now let's go on to step 3, formulas. Which equation or formula am I going to use that relates all of these guys and helps me answer the question? Which equation or formula do you think I'm going to use to help that relates the rates with the side lengths with answering the question? Which formula or equation do you think I'm going to use?
Equals 1/2 base height.
Yep, area of a triangle. Area of a triangle. So yeah, there's different ways to write area of a triangle. 1/2 base times height divided by 2. Any way you want to write it. There's no preference. The only thing is we didn't use B and H. We used X and Y, right? So let's change that to X and Y. So instead of B and H, base we'll say is X, height is Y. Okay, that was step 3. Go to step 5. Find the derivative with respect to time. So find the derivative of that equation. Okay. Well, to find the derivative of this, we're going to have to use the product rule. Yep, product rule. 1/2. So you can say 1/2 x is the first one and y is the second. You can do something like this. That works. Or you can leave 1/2 out. You can just say, I'm going to do the product rule of these guys, and then whatever I get as my answer, I'm going to distribute 1/2. That's okay. Whatever you feel more comfortable with, as long as you do it correctly, it's okay. All right, so I'll leave 1/2 out of it right now. So first times the derivative of the second plus derivative of the first times the second. Okay. Last step, plug it in. Well, I don't know what dA dt is. That's what I'm trying to figure out, right? Let's see. 1/2 x is 15. dy dt is -9/4 plus dx dt is 3 times y, which is 20. Okay. Multiply, finish this up. Let's see, we got 1/2. And then let's see, leave it as a fraction. So 15 times 9, -135/4 plus 60. Now I can distribute the 1/2. So I get -135/8 plus 60. See, 135 divided by 8 is a fraction. So what I'm going to do is I'm going to get a common denominator here. So instead of 60, what's 8 times 60? 40, 480. So -135/8 plus 480/8. Oops. So I get 345 divided by 8. How do I label that though? My question is, how do I label? So it's about 43, a little bit over 43. It's like 43 and an eighth. Yeah, it's 43 and an eighth. So how do I label that units? It's getting bigger by 43 and an eighth, a little over 43. How do I label that? It's area, right? So it's got to be feet squared, good. But it's a rate. There you go. Good. It's an area. It's a rate of an area. So it's feet squared or inches squared or whatever you're talking about, right? And then per what? Per second, per minute, what are you talking about? Okay. All right. Again, stick to these steps. Stick to the steps that I've been telling you, and I wrote, there's a reason why they're on one of the first slides. Before we do any work, I show you the steps because I've been teaching this a long time and I know where students go off. And I know as math students, you like steps. I like steps. If you give me steps, I can do it, right? If you show me how to do something, I can do it. That's why I gave you this to stick with, okay? So like I said, we haven't done any with number 4 yet. The ones I gave you today, the ones we didn't get to, those have things with number 4 in them. We'll do those. Don't worry about that. But I want you to be faithful to 1, 2, 3, 5, and 6. Okay? I want you to stay with those. We haven't finished. Let's see, which questions? How many questions do we have left? We have a few left. We have some volume ones. Okay? The nice thing about volume is they give you the equation. So you don't have to memorize it. They give you the equation. Okay? It's going to be the same stuff. It's the same thing. All right? All right, so we're going to finish this tomorrow. And Yep, that's about it. All right, guys. All right, so we're going to finish this. Don't lose that other sheet I gave you. Keep it with this one because it goes with them. We just won't get to it. Probably not till Wednesday. All righty. Uh-huh.
When you distributed the 1/2, you just the 60 was.
Oh, I should have done it there. Yeah, that's a good question. That's a good point. Yeah, look at the last problem. I didn't distribute. I distributed, but I didn't distribute to the 60. So when I distributed there, that should have been 30. Thank you. So that means this is going to be 240 over 8, which becomes 105 over 8. Yep, that's very important. Okay. Yeah. It's not posted?
Yeah, it was not on there.
When was it due? Let me double check.